Okay, let's dive in. We've got some really interesting research here, material that kind of forces us to put the standard history books aside for a moment and, well, listen to the stones themselves.
Yeah, absolutely.
Our mission today is a real deep dive. We're looking at a physical paradox, essentially, a single huge object that seems to challenge the whole accepted historical timeline just by being where it is when we think it is.
It's perfect for this kind of discussion, actually, because you have to stop just accepting the standard assumptions. We're going to drill down into the evidence around this one artifact.
Okay.
And when you look at it purely from, say, an engineering or material science perspective, it's basically technologically inexplicable in its supposed historical context.
Right. And this artifact is the granite box of Elephantine Island.
That's the one. You know, when most people think ancient Egypt, their minds go straight to Giza, the pyramids, maybe the Valley of the Kings.
There are big sites.
But we're heading way, way down the Nile for this. Navigating to this tiny little island, Elephantine Island. Historically, it was pretty much the southern border of ancient Egypt.
The frontier, really.
Exactly. The edge of their kingdom. So definitely not your typical tourist destination.
But hidden away there, amongst the ruins, that's where we find this paradox.
Yeah.
The sources we looked at describe it as just colossal. A massive container, perfectly symmetrical, apparently cut and hollowed out from one single solid block of granite. It's huge.
Monumental is the right word. And this isn't some later artifact, Roman or Greek work that might seem more advanced. No, the estimates place this firmly in the Old Kingdom.
Old Kingdom. So like 4,000 years ago?
Roughly, yeah. Contemporary with those early, really massive pyramids. We're talking ancient.
Okay, so its function, probably straightforward enough, right? Maybe for sacred scrolls, important relics, some kind of ceremonial use.
That seems likely, yes.
But you nailed the key point right away. The real head-scratcher isn't what it held, or even who used it. It's how on earth they made it.
Exactly. The hook, the real mystery, is in the execution. This isn't just some big, rough-hewn granite box.
Yeah.
It's a massive container where every surface, every single angle seems to be worked to this just astonishing degree of precision.
And this is where the engineering puzzle really snaps into focus, isn't it? The sheer quality of the craftsmanship.
It is.
Our research notes kept highlighting the level of precision is genuinely shocking. Modern stonemasons, right?
Yeah.
Even with diamond-tipped cutters, laser guides, computer controls, they'd apparently struggle a lot to replicate this box, the same flawless consistency.
And it's fascinating when you get specific. They talk about how close it is to perfect geometry. If you look inside, the corners, they're cut to almost perfect right angles, true right angles.
Wow.
And the walls aren't just flat or smooth, they're polished. Polished to a mirror-like finish, apparently, reflects light. This is about incredibly fine tolerances, not just rough carving.
So let's define the paradox clearly. It really boils down to the material itself, doesn't it? Which brings us straight to the hardness problem.
Exactly. We should probably mention the Mohs hardness scale for anyone unfamiliar.
Good idea.
It's pretty simple, just measures how resistant mineral is to scratching. Diamond's a 10, the top born. Granite, what this box is made from, it ranks a solid 7.
7. Okay, so that's tough.
Oh yeah. A 7 is seriously resistant. It's not easy to work with at all. And it's very abrasive itself. It just chews up any tool that's softer than it is.
Right. And the tools they supposedly had available back in the Old Kingdom.
Yeah.
What are we talking about?
Well, mostly simple bronze, even more likely softer copper tools, maybe some very basic iron ore, but nothing refined.
Okay, and where do copper and bronze land on that Mohs scale?
They barely make it to 4.5, maybe a bit less for pure copper.
So, wait. You've got engineers trying to cut and polish material granite, Mohs 7, using tools that are literally almost half as hard, like Mohs 4.5.
Precisely.
The tools should just crumple, shouldn't they?
Right.
Or wear away instantly.
That's a core issue. There's a great analogy in one of the sources we read, and it really hits home how big the problem is.
Yeah.
It's like trying to carve a block of modern, hardened tool steel using a piece of soft clay. Or maybe, at best, a chunk of aluminum.
Right, you just can't.
You simply don't have the mechanical advantage. Forget the mirror polish and those perfect, unwavering straight lines and right angles. The tool itself would just degrade long before you even manage to properly scratch the stone.
Okay, so that presents a fundamental contradiction. It seems technologically impossible based on our understanding of their tools. So what's the official story? The mainstream archaeological explanation for how this thing exists?
Well, the traditional view tries to tackle the hardness problem by bringing in two key things: time and abrasives.
Okay.
The theory basically goes that this box represents a colossal triumph of sheer relentless human effort, just grinding away.
Grinding. How?
They suggest using abrasives, mainly quartz sand or dust. Now, quartz is slightly harder than granite, maybe an 8 on the Mohs scale.
Oh, okay. So that could work.
Potentially. The idea is they used simple copper implements, not as cutters, but just as carriers for this quartz dust slurry. And then they just rub and rub and rub for centuries, maybe, relying entirely on the hard dust to slowly wear down the granite.
Centuries. That sounds plausible on the surface, I guess. Soft tools, hard dust, lots and lots of time. But wow, centuries. That raises a whole host of other problems, doesn't it? Logistical ones.
It really does. I mean, think about project continuity over centuries. How do you manage that kind of infrastructure project? How do you ensure the design, the blueprint, stays perfectly consistent from one dynasty to the next over generations?
Yeah, and the workforce.
Yeah.
Keeping people dedicated to that kind of mind-numbingly slow, repetitive labor for literally hundreds of years.
Exactly. The sheer organizational complexity needed for this centuries of grinding explanation, it honestly creates almost as many questions as it supposedly answers.
But let's say, just for argument's sake, they did solve those huge organizational challenges. This is where the actual physical evidence, the marks on the box itself, apparently throws a wrench into that whole narrative.
This is the absolute core of the scientific counterargument, yes.
If they spent generations slowly grinding this thing down with loose quartz dust, pushed around by soft copper tools, what kind of marks should we expect to see if we looked really closely, like under a microscope?
You'd expect very specific signs. If you grind a hard material like granite by hand using a loose abrasive slurry and a relatively soft metal tool to apply it, you're going to get certain telltale marks.
Like what?
You should find some unevenness, however slight, microscopic chatter marks where the tool skipped and vibrated. Slight variations in the flatness, indicating the tool wasn't perfectly rigid and the force wasn't perfectly uniform. Manual labor, even if it's incredibly meticulous, is just inherently inconsistent at that micro level.
Okay, that makes sense. So when researchers actually do look closely at the interior walls of this granite box, what do they find instead?
They find astonishing, almost unbelievable geometric perfection. The flatness of the surfaces, the way the walls are perfectly parallel.
Yeah.
It's achieved with a degree of tolerance that you just don't see in other ancient work that we know was hand-ground. It's practically non-existent elsewhere.
So the crucial counter-evidence, the thing that sort of screams out, is the complete absence of those expected microscopic uneven marks. The marks of slow manual grinding just aren't there.
That's exactly it. The finish looks almost machined.
Machined, wow.
The physical evidence seems to directly refute the traditional grinding theory. What the marks do suggest is something radically different. Meaning a tool capable of an utterly uniform cut. A tool that could hold its edge, or maybe more accurately, maintain a perfectly consistent path and pressure against Mohs 7 granite, and apply unbelievable consistent force across the whole surface, almost simultaneously.
That sounds modern.
It implies power delivery and precision control that we normally associate with, 20th or even 21st century manufacturing technology, not the Old Kingdom.
Okay, and that's the moment the accepted timeline starts to feel wobbly. The artifact itself, its physical characteristics, seem to refute the story we tell about how it was made. So if we step back now, look at the bigger picture. What does this single object mean for our whole understanding of ancient history?
Well, it forces us to seriously ask if there's a fundamental, maybe even massive gap in our understanding of ancient engineering capabilities.
A blind spot.
A huge one, potentially. If the tools we know they had, copper and bronze, simply cannot account for the finished artifacts sitting right there, then we have to start considering some of these non-traditional hypotheses that the sources bring up. Ideas trying to bridge that technology gap.
Okay, so if the physical evidence points away from the grinding theory, where do these analyses suggest we look next? What are some of these non-traditional ideas?
Right, and we should be clear, we're just reporting these impartially. These are theories that tend to emerge when the conventional explanations don't seem to fit the physical data.
Understood. So what's theory number one?
The first possibility floated is that this box is simply a legacy, a remnant of some lost, highly sophisticated pre-dynastic technology. The idea being that advanced engineering knowledge existed in Egypt before the well-known pharaohs came to power, and that knowledge was somehow later lost or perhaps deliberately destroyed.
Pre-dynastic tech. Okay, and some sources go even further back, right? Suggesting maybe a forgotten global history.
They do. Some analyses touch on the idea that this box could possibly be evidence for something like the Silurian hypothesis.
The Silurian hypothesis, what's that?
It's a pretty provocative thought experiment, really. The idea is, could Earth have hosted a previous, maybe even industrial level civilization long, long before humans evolved or developed our own recorded history? If such a civilization existed millennia ago, maybe this box is just something they left behind, a simple container to them.
Wow, okay, that is a massive conceptual leap. But I see how he tries to explain finding apparently impossible technology in the distant past.
Exactly. It's one way to potentially square the circle. Other ideas focus less on who might have made it and more on how it could have been done differently.
Like alternative methods.
Right. For instance, was the granite somehow chemically softened before they worked it? Maybe using some complex process or substance that we've totally lost knowledge of?
Softening granite.
If you could temporarily lower its Mohs rating, then maybe copper tools could become viable. Or, and this one is really thinking outside the conventional box, did they perhaps possess some kind of uh, simple yet ingenious acoustic or ultrasonic technology?
Acoustic cutting, like using sound.
Yeah, a way to vibrate the stone matrix apart at a microscopic level, or polish it using high-frequency vibrations rather than brute force mechanical grinding.
That's an incredible range of possibilities. From lost pre-dynastic knowledge to forgotten super civilizations to sonic technology, all stemming from this one massive granite box on a little island in the Nile.
It really underscores how the mystery of this box kind of transcends just Egyptology, doesn't it? It pushes up against the framework of historical science itself.
Which brings us right to the so what factor for you listening right now. If people in Egypt 4,000 years ago could achieve this level of uniform precision on super hard Mohs 7 granite, using some technology we currently can't define, what does that imply? What does it say about their scientific and engineering capabilities that maybe we've completely missed or just dismissed?
It's a huge point. We've maybe always judged ancient civilizations by the tools we find, the simple copper chisels, the bronze saws that survived.
The artifacts left behind.
Right. Instead of judging them by the most stunning, most technologically contradictory results they achieved, like this box, we might have been limiting our view of their potential based on what happened to survive the millennia, rather than analyzing the absolute peak of their abilities represented by things like this.
So this box on Elephantine Island is almost a perfect case study, where the artifact itself demands we reconsider the history books.
I think so. It completely changes the conversation. You don't necessarily need to dig up some rumored lost city Atlantis style to challenge history.
No.
You can just start with a physical object sitting right there in plain sight that simply cannot be easily explained by the accepted tools and methods of its time. It's the ultimate physical challenge to the standard narrative.
It just sits there.
Exactly. The granite box is still there today, perfectly polished, smooth. Just this silent, heavy challenge to pretty much everything we think we know about the people who built the pyramids. It really forces us to admit that maybe our historical knowledge has a significant blind spot, stretching back thousands of years.
So as you listening mull this over, here's maybe a final provocative thought to consider. If those telltale marks of slow manual grinding are completely absent, and you needed some method to cut and polish Mohs 7 granite with that incredible uniformity and mirror-smooth finish, what kind of energy source would be required? Forget manual labor for a second. What could deliver that sustained, uniform, powerful force needed? What kind of energy could they possibly have tapped into back then?
That question alone sort of redefines the whole problem, doesn't it?
It really does. Something to think about. Well, thank you for joining us on this deep dive into a genuine Stone Age paradox.
My pleasure. Fascinating stuff.
Absolutely. We will catch you on the next deep dive.